started. Hi, I hope you have had a great day so far. I'm Harald Bieringer, the CEO from Visplore. Thank you very much for joining us in today's webinar on time series labeling. Just as a rough agenda, we'll use approximately the first 15 minutes to introduce you to the topic, talk about some applications and challenges. Then we'll present two different labeling use cases live in Visplore. Finally, we'll conclude and hand over to the question and answer part. For this Q&A part, please feel free to ask questions anytime in the chat. We'll read out questions loud and answer them in the end. Okay, to get started, let's say a few words about time series. Time series data are booming nowadays, and this chart nicely illustrates that. It compares the growth of different types of databases. And what stands out is this upper line here. This violet line refers to time series database system. So what this chart tells us is that over the past 2 years, time series databases have steadily remained the fastest growing category of database. So I guess many of you probably encounter time series data also in your daily work. This can be from machinery in the production process, maybe from smart devices, maybe from energy meters, or many other types of sensors. The raw sensor data is typically much less interesting than applications of it. I guess every one of you has heard or even experienced applications such as predictive maintenance, usage-based pricing schemes, smart grids, and many more. So we may ask ourselves, what do these applications have in common? There is some analytics constantly processing the raw data in order to extract meaningful information from it. For example, detecting that a machine performed certain operations sometimes, or that the machine was idle. Doing such classifications is a typical example of artificial intelligence. To teach an AI to detect meaningful classes, basically you need two things. First, you need lots of historic sensor data. The behavior reflected by that sensor data should cover what you want to detect. So for example, all types of operations a machine can reasonably perform. And second, you need explicit information about which class occurred when. So looking at this example here, you see that the period of normal machine operation started in May and was followed by some shutdowns around mid of June. And unlike the raw sensor data, this class information is typically not readily available, but it must be generated before building a model. And this process is what we refer to as labeling. So you could define time series labeling as the process of assigning meaningful class information to raw sensor data before it can be used to train an AI. And the purpose of the AI is then to recognize the class from the sensor data. Here are some examples. Imagine, for example, you are a machine manufacturer. What you might be interested in is to monitor how your customers actually use your machines. So, for example, to know that operation A was performed 5 times or the machine was idle for 70% of the time. Another example is anomaly detection. One approach to anomaly detection is to learn all plausible states of a system and to classify data as anomalous if this behavior doesn't match any known label, like we see here for this oscillating pattern in the picture. And as a third example is fault prediction. In this case, the analytics learns to recognize patterns that occur before the fault event. So for example, here, we also see an oscillating pattern marked in orange that occur such shutdown periods. In all these cases, the AI learns to predict a class based on labeled sensor data. One thing you should bear in mind is that the AI will learn whatever it gets as input. So if labels are wrong or don't really match the pattern of the data sensor data, the quality of the results, the resulting predictions by the AI will suffer too. This is a typical example of the principle garbage in, garbage out. As you can see, good labels are critical for building high-quality AI models. Of course, building good AI models also require you to get other things right, such as choosing an appropriate type of model, tuning model parameters, and so on. But many data scientists argue that the quality of the input data is actually the most important factor. So here at the right-hand side, you see some quotes of people arguing that data labels are truly very important for getting good AI results. If you need to optimize an AI model, getting the input data right is typically the most effective thing to do. And this means you have an appropriate choice of representative input data as well as correct data labels. Unfortunately, this is easier said than done. Right, Thomas?
Yes, Harald, thank you. Hi, I'm Thomas Mühlbacher, CTO of Visplore. Now, it's as you said, having good input data is key, but that's easier said than done. Labeling sensor data can be quite challenging for several reasons, actually. Sensor data is typically massive, and it may have complex patterns. In the worst case, they are high frequent and multivariate. What does that mean? High frequent means that you cannot easily aggregate or smooth the time series without losing some relevant information. So here, for example, such oscillations or spikes, steep slopes, they may all be characteristic aspects of the pattern you want to label. So in such cases, it's hard to reduce the data, and so it stays massive. And multivariate means that you may need to consider multiple time series at the same time in order to label such data. So yeah, these are quite some challenges, but the biggest challenge is this. Labeling is one task in AI model building that still requires manual work. Sometimes it's the only manual task. And even worse, when you have very complex sensor patterns, you typically can't outsource this labeling to service providers. It's even hard for the data scientists sometimes to label complex patterns. So you really need the domain experts who can interpret this data and assign correct labels. So the time and the availability of the domain experts, usually of a small group of domain experts, can become a real bottleneck in a data science project. Each additional iteration for getting the labels right adds up to the duration and the costs of such a project. This is one of the reasons why 80% of the effort in a data science project are for understanding and preparing the data. You probably have heard this quote and know it also from your own practice. And therefore, it really pays, and yeah, it really pays to do the labeling efficiently. So how can you label data? There are multiple approaches. One is manual labeling. In simple terms, this means painting the labels while you inspect the data visually, like you see here. In certain situations, this can actually be efficient. For example, if you need to label historic data only once and the number of labeled periods is reasonably small, just a few anomalous situations. Another approach is trying to label the data automatically. This may be based on rules, like whenever the temperature falls below 0 degrees, label it, or by searching for certain patterns in the data, like you see here. So we have this one pattern here, and we can search automatically for further occurrences, like here. Of course, if this works well, it's great. In general, however, the patterns may be more complex, and it may also not be possible all the time to identify rules by hand. After all, that is the part of the machine learning, the job of the machine learning part, actually. And therefore, the third category are semi-automatic approaches. Here we can distinguish two categories. The first one is to start with labeling data manually, and based on this input, an algorithm makes suggestions for further labels. This is semi-automatic because the human and the machine work together. The second one is the opposite direction, to start with an initial rule for getting some labels right and to correct that output manually. In practice, it's often a blend or a mix between the two. So for example, here, as you see in this short sequence, we start again out with some example that is manually specified and use this to come up with automatic suggestions. And then the domain expert can come and correct these suggestions by auditing the labels. Like for example, clearing this label here because it's not an oscillation. And this is where Visplore comes into play. Actually, all of these clips were from Visplore. So Visplore supports manual labeling of large time series data, but it also allows to define labels based on rules or to search patterns. And this is very important. These rules and patterns can also be automatically applied to new data when they come in. And always, the results can be audited and corrected interactively. When you're done, the labels can be exported or shared with others. All right, now it's demo time. Let's look at some examples of labeling in action. The first example is from labeling data from a turbine. It shows you how you can label large sensor data by hand to audit and correct the results of an initial labeling algorithm. The use case is from Verbund, Austria's largest producer of hydropower. And the data is from a hydropower turbine. The goal in the use case is to monitor the health of the turbine with an AI. For example, if some temperatures get too high, a warning should be generated for the turbine. To train this AI, we have historical data from the turbine operation, along with labels of the operation states. So here, you see the oil temperature over several years. Green are periods of normal operation, yellow are some shutdowns, and red was a long renovation period. The labels you see here come from an algorithm in scikit-learn in Python, but they're not 100% correct. So the expert needs to validate them. And this is what I'm going to show you. So I start the demo and switch over to Python. All right, so here in our Python environment, we have our data frame and the initial labels from an algorithm here. And we can use the Visplore Python API to just start Visplore from Python and start exploring the data frame. So Visplore is started, it's sent over. And then in Visplore, it looks like this. So here you see the time series of that labeled oil temperature. Up here, you see the different labels that have been given by this algorithm. And for example, you can see here how often each of these labels has occurred. We can hover such a class here and see when the label normal operation was given to the data. And here we see, for example, that it's not right all the time. Here, after this long renovation period, for example, this cannot really be called a normal operation yet, if we look at the rest of the data. And so what we can do is we can start an interactive labeling correction workflow now using the data from the labels that we have. So for example, we could come here and label all of these periods here still as part of these renovations. You see how it turns red. So we have painted these labels to become the other label. All right. So what else do we have? We see, for example, there are some interesting normal operation periods here in the beginning. And actually, a bit more. these periods here were rather short to be called normal operations maybe. So again, what we can do is we can select this and add them also to the shutdown periods, making them yellow. Okay, so you see how easily you can really relabel the data here. And now we have some nice labels. We could use all the green points now for training our monitoring rule for the normal operation. However, we have a long period here. These are actually 4 years of data. And there were these renovations going on in the middle. So maybe the whole system here has changed after these renovation periods. And to investigate this, we can explore this data a bit further. For example, we can include another temperature time series in the analysis. And here we see indeed the system has changed, because after the renovations, these temperature levels were pretty much alike, but before the renovations, they were actually quite different, as you see here. So we might conclude that these periods here actually were not really normal operation from today's point of view when we want to predict the future then. And so what we can do is just select the normal operations in here and then relabel them as something new. You can call this obsolete, for example. Then we see that we have really nicely labeled our data now. The normal operation in green for training our AI, and all the other data parts here are labeled nicely as well. And when we're done, it's quite easy to export these labels back to Python to use them in our AI. So let's go back here. And with one more line of Python code, we can retrieve the labels from Visplore. And you see here now, for example, that we have 18,000 occurrences of this new obsolete label that we just added. So what have we seen in this example? We really needed the domain expertise as well as the flexible data exploration to get a full picture in order to correctly assign the labels as needed for this workflow. Okay, and with this, I hand back to Harald for the second example.
Thank you, Thomas. The second example is from manufacturing. It's about a milling machine from RHI Magnesita, the world leader in refractories. For those of you who don't know the term, milling machine in German is called Fräse. So this milling machine is used to manufacture different types of goods. However, there is currently no piece counter installed that would distinguish the various goods. Such a piece counter is necessary, for example, to perform analysis regarding the cycle time. Rather than installing an expensive new hardware, the goal here is thus to extract the number of reproduced pieces from available sensor data, such as the position of the horizontal axis of the milling machine. Okay, and with this, I also switch to Visplore. One day of process data has already been imported to Visplore directly from the process historian. In this case, this is Osisoft Pi. You're looking at the cockpit called Pattern Search and Distribution, which is a feature of Visplore Professional. Now, let's start by zooming into the time series, here called horizontal axis. Now, you can clearly see the individual milling operations. You also see that there are different types of pattern. So here in the beginning, there is one type of pattern, and after some time, the type of pattern changes. Let's start labeling the milling operations. Maybe for this, zoom in a bit more. Okay, and all I need to do is to mark up the first milling operation by dragging an interval directly in the chart. And then, once I did this and told the system what one milling operation is, the pattern search feature of Visplore Professional is really helpful. This can be found here. So let's call this first pattern simply pattern A. And then Visplore automatically searches for all similar milling operations. Now let's discuss a bit what we see here, because there are several views that interact with each other. What we see is that Visplore found 8 milling operations. Those 8 milling operations that are most similar to the reference pattern. What we see is that these 8 milling operations are highlighted here in the timeline plot below. And in addition, those 8 patterns are also laid on top of each other here in the upper view in order to compare them better. Finally, here in this table, it shows some details and statistics for each of the pattern. When we hover a row here, we see that this milling operation gets automatically highlighted in the other views, to the left and to the bottom. Now you may ask yourself, why have we only found 8 patterns? Searching for some similarity is always related to defining a threshold when to consider something as not similar enough. And this is something that can easily be tuned here in this window. The threshold is represented by this red line. And when we put this red line a bit further to the right, so just like here, we increase what is considered similar enough to be found as a pattern. Now, actually here, as you see in this counter above, the number of found milling operations now have increased to 20. And now this actually looks pretty good. Okay, so conclude for type 8 now, and let's turn to the second pattern. Just scroll a bit further to the right until the second type of milling operation occurs. And then what I do is pretty similar to before. I just select the first occurrence here. Then I use the pattern search feature and call this pattern B. Again, we get some results, namely those which are most similar to our reference pattern. In this case, Visplore suggests 43 matches. Again, we can increase the threshold a bit further to the right, for example, like here. And this gets us now over 300 matches. As you can see by the black highlights in the timeline, this pattern occurs over and over until the end of the data set. So what you see here is that here we'll find black parts until the end of this data set. However, when we look a bit more closely to this upper view here, we see that there are some differences. Especially the third peak looks different for some of them, milling operations. So now we might be interested to validate results a bit. And to do this, we can simply select milling operation in this upper view. Visplore offers a line selection tool for that. So we just need to select, draw a line here, and each pattern intersecting this line is selected. So this allows us to locate the corresponding milling operations in the timeline view. And for example, as you see here, for those 3 milling operations here have a bit of a longer third peak. But nevertheless, we can consider this the same milling operation. So let's look for some other type of anomaly. Just select another pattern here. Zoom out here a bit. And then what we see is, in this case, the third peak looks actually quite different. Here, it's actually fourth peak occurring. So, nevertheless, we also have other peaks like this one here, where we have such a long period here. Nevertheless, we can still consider these as anomalous examples of the same type of milling operation. So let's accept this pattern here. And let's look at the entire data again. Now, to distinguish the two patterns, we can create a new data attribute. Just need to click here and say we want to create a classification which contains those two patterns, and let's call this operation types. Okay, what we also need to tell the system is that we want to use this now for further manual labeling, which also discriminates those two classes by color, as you see here. And when we look closely, let's zoom in here, you see, for example, that here a milling operation has not been found because it was actually much shorter. So what we can do here, similar to the first example, we can select it and label it as pattern B. Okay, so the data seems labeled now. So what's next? As one option, we could export the labels to Python, MATLAB, or R, just as we've seen in the first example. We would typically do this for building an operational AI that implements the piece counter on streaming data. As another option, we can continue here in Visplore. So for analyzing cycle times, for example, we can use Visplore to further derive a piece counter as an additional time series. And the first step to do this would be to turn these patterns here into indicator time series. This is something I will show you. So here, let's take pattern A and just say we want to add this as a variable. What we get here, we'll zoom in here a bit more closely, is that we see that for each of those patterns, there is such a rectangle that comes from this additional time series called pattern A. So this would, for example, be a first step to deriving such a piece counter directly in Visplore. Very importantly, Thomas already mentioned this, all that we did, defining the search patterns, defining additional time series, and so on and so forth, this can be automatized and applied to new data. All that we need to do here is to save what we did as a file. See this icon above. And once we have additional data, so for example, assume you now have data from the next day or from another week, just loading this file will re-evaluate all the patterns on the new data and label them automatically. And yeah, last but not least, it's also simple to get what we have back, for example, to Excel. So all I need to do is just here to click on export, say I want to export the data here to the clipboard. Then let's switch to Excel and just paste the data here. So what we see is that we now did an export of the data. This was actually the time series we have looked at. These are the timestamps. These are the patterns, and so the labels. You see that some are called rest, others are labeled as pattern A, and the corresponding time series we derived from it. All right, so let's get back to the slides. So this second example showed how you can use pattern search to automatically label machine operations. This makes it easy to extract meaningful information from raw sensor data. In this case, it was a piece counter per product type, saving costs, for example, for installing this counter as a hardware sensor. So we hope the two examples could give you a good idea about what labeling looks like in Visplore. Worth mentioning, besides labeling, Visplore is a high-performance technology for generally exploring large multivariate data and especially large time series data. One aspect that makes Visplore truly unique is that it comprises a set of ready-made tools for topics like correlation analysis, as you see here on the image above, and further issues such as root cause analysis of process data, regression, industrial quality analytics, and much, much more. Now, please allow me to say a few words about our background. Visplore is based on more than 10 years of research and development at Austria's leading research center in visual computing, called VRVIS. Our company is backed by the European venture capital B2V, and we are currently a team of 11 people. Our customers mostly come from industry, the energy sector, and consulting. As you can see some logos here at the right-hand side of the slide. Besides labeling, our customers use Visplore, for example, to shorten the time for data quality assessment for all types of evaluations, and for explaining root causes of faults and process optimization in general. Also, very importantly, also to simply generate great plots for reports in much shorter time. Okay, so let's conclude with some key aspects of this webinar. First of all, getting data labels right can be a very hard, or even the hardest and most expensive part of a data science project. Still, improving the quality of the labels is important and can be the most effective way for optimizing an artificial intelligence. Second, as you've already seen in the examples, every labeling task is different. So the examples suggested that there is no general one-size-fits-all. One time you have a few things you want to label, in another time you want to label a large number of recurring patterns. In practice, data exploration, manual labeling, and automated approaches need to go hand in hand in order to be most effective. And this can save you very much time in your data science projects and actually leads to better labeling results. Third, labeling is not an island. Labeling is part of a workflow that sits between extracting the data and building the actual AI model. For this reason, Visplore offers a seamless integration with data science platforms such as Python, as you've seen in the first example, really in order to combine the best of each world. And finally, we have heard a lot about AI now. And of course, labeling data for AI is a very important topic. Nevertheless, AI is not the only application of labeling. So for example, it can make very perfect sense to annotate graphics for presentation or discussion with colleagues. So just to make a visualization more effective. Okay, and now it's up to you. If you haven't already done this, you can try to label data yourself in Visplore Free. It's a Windows application which you can download from our webpage. It's easy to install, even without admin rights. In order to get started with labeling, please follow our step-by-step guide to labeling. We recommend this will save you much time and get your results in minutes. So yeah, we recommend that you check this link here in the online documentation. And if you want to try it out yourself, please follow this guide that you see here for you. And we also have an extra bonus for all of you. We gladly provide you with Visplore Professional for 1 month to all participants of this webinar for free. So this will allow you also to try out the pattern search yourself. And we are very much looking forward to getting in touch with you and to discuss your specific use case. In order to get Visplore Professional, please feel free to just contact us. So happy exploring your data. Okay, so that's for the presentation part. Before we come to the Q&A, we want to thank you very much for attending this webinar. We hope we could provide you with some new information and maybe inspired you a bit about how you could improve your own labeling tasks. Now the floor is yours. If you have any question, please ask via the chat feature.
All right, so now for the Q&A part. let's switch back to screen sharing. All right, so we see that we have already gotten some interesting questions in here. As you have not, if you have missed this before, you can still post questions in the chat, and we will call out some interesting ones. And if there's not enough time for all of them, you can also contact us afterwards. We're happy to discuss any questions. All right, so let's start with the first question that has come in here. Can you label only time series data?
Actually, no. Visplore is not limited to time series data. You can analyze and label any multivariate data set. So, for example, you could use Visplore to label groups of customers or do any other type of segmentation of your data. However, the focus of Visplore is on multivariate and time-dependent data. So Visplore is not designed for labeling image or text data.
Yeah. So maybe here's a question. Can I use the labels also on new data?
Yes, so I mentioned this in my second example, but actually you haven't seen it. So the answer is yes. You can define labels based on rules or pattern search features you've seen, then store it to a Visplore file, and then to apply this file to new data, which evaluates the rules and the patterns on new data.
Okay, maybe here. Is data labeling applied to all time series within a data set or only to the one selected?
Actually, the labels are, you can think of the data as a kind of a data table, just like an Excel sheet. And the result of the labeling would then be one additional column here of this data matrix. Yeah. So the answer is it's actually applied to all time series, and is a way to kind of classify the rows of this data matrix.
So you can think of it as a new categorical data column that holds the labels, but they can be defined using any of the sensor signals and so on that you have in the definition. Maybe this is also related to another question here. Any comments on how the pattern search would work with multivariate signals?
Yes, so we didn't show this, but the pattern search actually also works on multiple time series. So for example, if we would have looked at 2 or 3 or 4 time series, then actually the search would, the distance metric underlying the search would be, would consider all of these time series for evaluating the pattern search. So the short answer is yes, it's also applicable to patterns that need multiple time series to be defined.
Actually, this is related to several other questions. So I think several people asked for how about pattern finding in case of interplay of 2 or more parameters. And yes, I think there were some other questions also asking similarly. Maybe this one, how do you label a huge data set, meaning more than 1 million, consisting of various words, sentences, and combinations?
So maybe let's first say a few words about data size that you can handle with Visplore. Regarding the size, actually there is no hard limit. Yeah, depending on the hardware, a limit for getting reasonably interactive feedback is a few million data records, yeah, and up to a few hundred data attributes. So much that relates to the size. Actually, regarding the aspect of words, sentences, and combinations, I think this would be something that would need to look at in detail, how to refer this, because actually Visplore is designed to work on structured data and not directly, for example, on text data. Yeah? So as a type of unstructured data. Yeah.
Yeah, I mean, there are features, for example, to look for free text in categorical columns if you want to label certain instances that contain some word, maybe used directly for labeling. Yeah. Okay, here's a question. Is it possible to change the pattern search parameters, for example, the threshold via available APIs such as Python, R, etc.? I think that's a nice idea for future work, isn't it? For
yes,
tuning
it is.
that, yeah.
So what you can do is you can tune the pattern search in several ways. Like, for example, you can say whether the pattern search take the level of the time series and the range into account or not. Yeah. So there are use cases for both. But no, right now there is no way to directly tune this via the Python API.
Maybe also related to the Python API, here's a new question. If I have audio files after labeling, would I get labeled segments of the audio file? I mean, this is interesting. If you have, for example, an audio file where you extract, for example, a time series, yeah, let's say some feature over time from that time series, then you could use the Python API, send this to Visplore, annotate it there, get the labels back, and use this information, for example, to annotate again something in the audio file using Python, or also playing parts of the audio file that you have labeled. So actually, you can think of this Python integration as quite a nice gateway to linking it to applications that maybe go beyond the scope of the labeling in Visplore itself. Yeah.
So what else? There we have one, is there a functionality for predicting labels automatically, finding some similar states in multivariate data? So yes, this is actually what this pattern search does, if I understand the question correctly, that you can to find similar states. And as I mentioned before, when you basically what you see as a highlighting, for example, so maybe this is sometimes not immediately clear, but what you see, for example, when multiple instances of a pattern are highlighted, this is just the result of the pattern search. What actually Visplore stores is the definition of the pattern, yeah, and kind of the parameters of the algorithm to evaluate it. Yeah. So when you store it to a file, this is what you can then reapply to new data, and this is why you can reapply to new data.
Maybe another way of understanding that question is if you have, for example, a time series with labels, and then you get some new unseen cases, and you want to search if these cases have occurred in the past and apply the same labels that you had back then to your new data. Yeah. Kind of in the direction of a decision tree logic or something. I mean, that you could do by sending the labeled part and the new part to Visplore as part of the same table, and then selecting a pattern in the new one where it happens and see which categories or which labels are the most prevalent back there. Maybe not fully automatic, but you could get an idea of which labels are the most likely for your new cases. Yes, I could imagine this.
And maybe one more thing to add here. So what we've seen in the second example is basically that each type of pattern defines a new label. Yeah, this is not necessarily the case. So what you could also do is to say you have 2, 3, 4, 5 different patterns that still define the same label. Yeah, so this is something that can be defined. Yes.
So maybe as our time is approaching, I think we have time for a few more questions. Maybe here are two that are kind of similar also. There's a question where the tool is hosted. Connect via API, but how works it in the back end? And also similar question, runs Visplore locally, or does the customer get access to a central server? So maybe we can say one or two sentences about the deployment.
Yes.
Yeah,
want to answer?
I can. So there's actually multiple ways of doing this. You can install Visplore locally on your laptop, for example. It doesn't need any special hardware for that. So it runs basically anywhere in your Windows laptop. Or you can deploy it also on a server, let's say a Windows server that can be virtual, it can be a real server, where you connect via RDP, for example. So, but it's not a backend service only, but it comes with this front end. So you would always interactively use it like this. And via the APIs, maybe that's also part of the question, you can start Visplore, run some operation, like applying label definitions that you have, get the results back and close Visplore again. So it's quite possible also to automate it to a certain extent, also export some images. But regarding the actual use, it would be a desktop application more or less that can also be server hosted, but interactively. Yeah.
It's very easy to set this up. Yeah. Visplore 3, for example, doesn't even require administration rights to be installed. Yeah. So, and right now, still Visplore Discovery and Professional do require administration rights, but with the next release in a few weeks, we will also get rid of this. Then basically you will be able to install Visplore, all versions of Visplore without administration rights.
Okay, maybe it's time for another short question here. Can I do all of this in the free version?
With Visplore 3, what you can do is to label time periods manually, as I've seen the first example, and also define labels based on conditions. Like, let's say, apply some label whenever some variables are between certain thresholds. What Visplore 3 doesn't offer is the pattern search feature. But what Visplore 3 also offers is the connectivity to Python or MATLAB, as well as you can also load your own CSV files. So you can label your own data and get back the results.
Yeah, and if you want to try out the pattern search feature, of course, it's possible just to approach us as attendees of this webinar. There's this special thing here. Okay, well, I think this kind of concludes also this Q&A session. We don't want to.
Yeah, it was unfortunately there were really many questions. It was unfortunately not possible to answer all of them, but we see the questions, and those that we didn't answer, we'll just write you a short email and try to answer the questions per mail. And as already Thomas said, when there are more questions, please just contact us and we'll get back to you as soon as possible. Okay, so, this concludes our webinar on time series data. Thanks to everyone, especially here for also you staying until the end. We'll send out the link to the video recording in a few days. And we're happy if you join us again for the next webinar, which will be announced on our webpage and also through our newsletter. So if you haven't also already done this, please subscribe to our newsletter to stay tuned. Thank you and enjoy the rest of your day. Goodbye.
Thank you. Bye-bye.
Goodbye.